All right, here are examples for triangle proportionality. Example A says that there's a triangle with its mid-segment drawn below, and we're supposed to find out what the ratio that the mid-segment divides the sides into would be. So here's the three sides of our triangle down here, and our midpoints are here marked in blue, now in orange. And what we need to do is find out what the ratio of this segment from our top vertex to the midpoint, how that ratio compares with this down here. So we know that the first segment here is 10 units, and it's marked that way. And the second segment is also 10 units. It's also marked that way. So those two are the same. So that ratio would be 10 over 10, or 1 over 1. Yeah? The other ratio is marked as 8 and 8. Again, 8 over 8 is the same as 1 over 1. So the ratio of these segments that the midpoint creates is a 1-to-1 ratio. And that makes sense because the midpoint is supposed to divide those sections into two equal parts. That's why it's called the midpoint. It's the middle of each of those lines. So it would certainly make sense that the segments that are left relate to each other equally, 1-to-1. Now let's take a look at example B. Example B says, in the diagram below, EB is parallel to CD. So we have this line here is parallel to this line here. And we need to find BC. Well, if these two lines are parallel, then the ratio of, in this case, ED would be, compared to EA, would be the same as the ratio of BA compared to CB. So if we say that our missing segment here is X, then if we put the smaller segments on top in a proportional statement, we could say that 10 compares to 15 in the same way that X compares to 12. As X will be our shorter segment here on the bottom, right? So then we can cross multiply, and we'll get 15X equals 120. And if we divide 120 by 15, and we get our trusty handy-dandy calculator up here, 120 divided by 15, we get 8. So divide both sides here by 15, cancels by 15, gives us X equals 8. So BC then must be 8 units. All right, let's take a look at example C. Example C says, is DE, so this line here, is it parallel to CB down here? And we'll do it in yellow. So is our orange line parallel to our yellow line? Well, if it is, then we could use our proportionality statement to say that this segment here from E to B, this 8-unit segment, must be in the same proportion compared to the rest of its line, which is 24, as this segment here, 6, is to the rest of its segment, 18 here. So if those two proportions are the same, then these two lines are parallel. So let's see. We put 8 over 24. Is that equal to 6 over 18? Well, we can cross multiply if we want, but let's reduce first. 8 goes into 24 3 times, so that says that this ratio here is the same as 1 to 3, right? 8 goes into 8 once and 24 3 times. And then 6 goes into 6 once, and it goes into 18 3 times. So then we don't need to do the cross multiplication at all. We already know that the ratio is the same. So if the ratio is the same, then yes, the two lines are indeed parallel. Sort of the reverse of that statement that we used before. And that's all we got.